Amitabh Ghosh, who joins me from the Andaman Islands in India. Amitabh is a scientist who has, I believe, been working on NASA Mars missions for well over 20 years. Amitabh, as we prepare to watch this rocket launch, the telescope in particular we're talking about, what differentiates it from previous telescopes? People might be aware of things like the Hubble or the James Webb. What makes Euclid special?
Right. So the objective is different. So if you think about it, you just said, right, 95. So the universe has 1 trillion galaxies, and each galaxy has a trillion stars. So that means there are one followed by 24 zero suns in the universe. But apparently, this huge number of suns is 5% of the matter in the universe. So dark matter is something we cannot spot because it does not interact with light or electromagnetic radiation. It does not emit, reflect, or absorb light. So we cannot see it. But it is there. How do we know it is there? Because the motion of the galaxies, the motion of the suns, the motion of the black holes predict that there should be more mass out there than we can see with the telescopes, the infrared and the um, visible range telescope. How is it different? Webb telescope is looking out in the infrared for the early universe, 10 billion years before. What were the early galaxies look like? What does the early suns look like? This is looking to map the entire universe to see what is the mass distribution and what are the shapes. And from that, it's trying to infer um, how much dark matter is present where. And the second thing that this is trying to measure is dark energy. So you might have heard of Hubble's law. Hubble's law is nothing but the further a sun is from us, the faster it is moving away from us. So that's called Hubble's law. But it is possible that the rate at which it is moving is not constant. So it was, and that defines whether the universe will keep on expanding uh, with time or at some point contract. So there is a force there which is called dark energy, which is keeping the universe to expand. And so this unique mission is equipped to answer these two very important questions about dark matter and dark energy. Hubble looks at the universe in the um, visible spectrum, and then
Okay,
the
Amitabh, I
James
apologise
Webb.
for interrupting you. I think we're at less than T minus 10 seconds, so we're just going to watch the pictures now of the Falcon 9
Absolutely,
rocket at Cape Canaveral.
absolutely.
Visual propulsion is nominal. Vehicle is pitching downrange.
So there we have it, the Falcon 9 rocket, the SpaceX rockets. Off it goes, carrying the Euclid telescope off into space. And my guest, Amitabh Ghosh, I imagine you've been involved in more than a few of these launches. Just how nervous will all the scientists who've been working towards this be at that moment?
1 minute and about 12
It's
seconds.
they're very, very
That's
nervous.
Q
You
is
know,
the highest
this
amount
is
of
just a
aerodynamic
television
pressures.
moment,
That's the largest
10
structural
seconds,
load a
20 seconds,
vehicle will see on a
but
segment. We
it
throttle down
is
those
the
engines
work of
just to
thousands
pass
of
through.
scientists over 10 years, maybe. They've worked very, very hard. And, this point, if it fails, everything is lost. So it is a huge deal that it is successful.
Well, fingers crossed, everything's looking good so far. I think we've got just under 1 minute left, and I just want to ask you, if this all works and goes to plan and the things that the telescope designed to do, it does, what potential advances could there be for mankind from this?
It's going to be huge. Okay, so one direct answer is most discoveries, most big scientific discoveries are serendipitous. So you don't really know what they're going to find. But there is two big questions here about dark energy. So if everything that we see, the 1 followed by 24 zero suns that we can see with the Hubble. If that is just 5% of the mass, where is the 95%? How is it distributed? What does it look like? Is it something made not of atoms or not of electrons and protons? What is it? So it might change the very fundamental understanding of the universe. And
Amitabh, I do apologise.
dark
We are going to have to wrap it up there. Just 10 seconds to go on our broadcast. And as that Falcon 9 rocket's well off on its journey into space with the Euclid telescope, we will conclude our broadcast. Thank you to you and thank you to our